Okay guys, this is going to be a fairly long video because I want to do like a little briefing on this engine that we're building for Andy Kruger. And well, actually we didn't build the engine. What we did is we fixed the top end of the thing. There were several issues with this, and Andy had it at several different places and they couldn't get this thing quite right, so we ended up with it, which happens to us a lot. We get a lot of engines from other shops and we're fixing this stuff all the time, and I don't usually make videos about it because, this isn't about bashing another shop. All this is I just want to let people know there's a reason that we charge what we charge to do what we do. Now poor Andy, he's had this thing to so many different shops, and he's got literally 3 times as much money in this engine now that he would have had if he'd have just brought it to us to begin with. But instead, you know, and for whatever reason, maybe because he didn't know we were around, because I don't advertise. You know, I've been in business 43 years and it's all word of mouth. The only advertising I really have is I put pictures and stuff on Facebook and YouTube, and which I guess can be considered advertising, and we got a website. And thank God for Angelo Mendetto, because he's the one that did the website for me. Otherwise I wouldn't even have that. And he's a great guy. We did an engine for him, painted his Trans Am, and a big shout out to him for helping me out with that. But anyways, so Andy Kruger's got a Pontiac, what he thought was a 461, and after we pulled the heads and done some inspection on this thing, we found out that it's actually a 4-inch stroke crank with a 4,155 bore. So it's 435, somewhere in there, cubic inch motor. So first of all, it started out almost 30 cubic inches less than what he thought he had. The bottom end looks really good. We didn't tear anything apart. We didn't even pull the pan off this thing. We just looked down through the valley where the cam's at to make sure that it had good rods in it. And you can tell by looking at the top of the piston, it's got a good piston. It's a forged piston, forged rod. Looks like the crank's forged too, but it's a 4-inch stroke, which is good. Nothing wrong with that. I like it. You know, just that little confusion for Andy in case he ever wanted to, you know, change something in the future. He wouldn't have known what he had. So now we know. We fixed several things with this thing to get the thing to run properly. And I'm going to just start with what I'm thinking off the top of my head, because it was numerous, and these are the main things we fixed. But number one, the compression ratio, whoever figured this didn't figure it right, and it was only 9-to-1 compression. So with aluminum heads, you can run 10.5, 11-to-1 compression on 91 to 93 premium pump fuel, because the aluminum dissipates heat so rapidly that it's not like an iron head where you can only run 9.5-to-1 compression. You can run 10 and 10.5, even up to 11.5, believe it or not, with enough overlap on the cam. So that was one of the things we addressed. We had to fix the compression on the engine after we determined what the stroke was on it and the bore size. The other thing that we did was the valve job. The valves were not sealed. We pulled the heads because we did a leak down test, and I don't know if you guys know the difference between a leak down and a compression test, but a compression test just tells you how much cranking pressure you have in the cylinder, and doesn't necessarily tell you that you have a leaky valve or head gasket or whatever. It just tells you what the compression is and if it's even from cylinder to cylinder. A leak down test, what you're doing with that is you back the rocker arms off and you pump air in the cylinder, and you have 2 gauges, one on each side. One you set at a predetermined amount, let's say 100 psi, and the other one you read it, and whatever that reads gives you the percentage of leak down you have in the engine. And so ideally you're never going to get 100%. So if you set it at 100 and you get like 97, that's really good. That's about a 3% leak down. We were getting anywhere from 35 to 40% leak down on this engine. So we knew the valves weren't seated, and because we fired this engine before we ever tore it apart. Andy sent it to us complete. We put it on our run stand, we ran it. We thought, man, this thing's just running so bad we can't really tell what's going on. So we had to do numerous tests before we tore it apart, and we did. So anyways, we got that. We determined that several exhaust seats and a couple intake seats were not seated, and that's where our compression was going. So we had to redo the valve job, which, because the seats were so out of concentric with the valve, we ended up having to replace three or four of the exhaust seats. I don't remember, I gotta look at my paperwork, but we replaced several exhaust seats, and we had to sink the valves. And I don't ever like sinking a valve, but the thing of it is, we had to do it in this situation, because if we did not, we would have had to replace every seat in the head, and that gets expensive. So we did what we had to do to make it right, and it's fine. There's nothing wrong with that. The only bad part about it is when you sink the valve, you're putting the valve deeper in the chamber, and so whenever that happens, you've got to unshroud that valve in the chamber. So, and we put pictures on Facebook of what we've done there too, so so you guys can understand and see what that's all about. But we unshrouded the valves, which obviously makes the chambers bigger, so that even reduced the compression more. So then what we had to do is we had to mill the heads to get the compression up where we wanted it at. And this particular combination, where Andrew is at, he's only got 91 octane fuel, so we set the compression at 10.5 to 1 is what we're calling it. It's actually like 10.42 to 1, but it's real close to 10.5. So we're just going to call it a 10.5 to 1 motor or engine. And so that was the other thing we had to fix. Then, of course, whenever you do that, whenever you do a competition valve job and you got to sink the valves as much as you do, it takes a lot of material out of the cylinder head bowl area. So that led to, you know what, I told Andrew, I says, at this point we might as well port the heads, because the heads weren't ported anyway. So we went ahead and ported the heads and matched all the bowls up, blended everything, and matched the gaskets, which is a good thing that we did, because then we found out that whoever gasket matched the head before did not place the head or intake gasket in the right position, and they had it too far up, and because of that, the bottom of the port was kind of being exposed. So we had to reposition all that, and we got the proper gasket on there, and so then that led to, we had to mill the intake manifold, because we took 75 thousandths off the heads to get the compression up where we wanted it, 75 or 80, somewhere around there. And then, of course, the intake manifold's not going to line up, and so then we had to machine the intake 100 thousandths to get it to line back up. Actually, we took a little more off the intake because we needed to line up with the port that got gasket matched wrong, so we got that straightened out. And honestly, the gasket match thing, I think, was Edelbrock's fault. It looked like Edelbrock just messed up, you know, is what it looked like to me. So, but anyways, we got that straightened out. We got the intake positioned right. So the other thing we done was we separated the water crossover from the intake manifold. And the reason we did that is because the intake manifold wasn't lined up on the intake ports. It was offset a little bit. So once you separate the water crossover, because without it separated, it's stationary. You can't move it fore or aft. So what we did was we cut the water crossover off, trimmed the front of the intake manifold. That way we could move the intake and position it where we needed to overtop the intake ports. So we did that, got that straightened out, ported the intake to match the cylinder heads, which required quite a bit of porting because the intake port configuration the way it was. So we got that all straightened out. And then the other thing that was going on with this thing was the distributor. It's got an MSD ready to run distributor in it, and those are junk. Don't run them. I'm telling you right now, don't waste your money. The distributors, they're out to lunch. I don't know what's wrong with them. I don't have time to figure it out. I just know they don't work. And so what we did with his, so we didn't have to buy another distributor, we bought a pigtail from that MSD sells, and we took the circuit board and the control module out of the distributor, which makes it ready to run, and just made it a crank trigger. Or a trigger wheel. That's all it is, and that's what the MSD billet distributor is anyway. It's just a billet or a trigger wheel inside of it. There's no other thing, nothing else in there except for mechanical advance. So we converted it to like a standard MSD billet distributor. So that was that. Because of that circuit board in there, it was causing a misfire that we couldn't quite figure out. We knew that, you know, we didn't have our cylinders sealed up when we were running the engine, but it had like an unusual misfire that wasn't because the seats weren't seated. It was, and we determined it was that distributor. And, I knew that kind of going in because every one of those ready-to-run distributors that we've tried, every one of them misfires, every one. And I don't know why it's doing that. It's something to do with the circuit board they have in them. So anyhow, we got rid of that, converted to just a standard billet distributor. The advance curve was out to lunch on this thing, so we ended up recurving the distributor. We put the proper springs and MSD makes a little bushing that goes in there so you can limit the travel of the mechanical advance. So we put the proper bushing in there for the way we like to set the advance curve for our combinations. One of the other things I wanted to change on this setup that I tried to do, but we couldn't get a cam in time, is I don't like the lobe separation on the cam in this thing. Although it is pretty crisp, but it would make more torque, mid-range torque, with a tighter lobe separation. This camshaft is a 242, I believe, or maybe it's 248, 252. And I do believe it's a custom ground, but it's got a 114 lobe separation. And that's just too wide. In my opinion, that's just way too wide. And the reason that engine builders do that is because it makes the thing easier to tune. And you don't have to, screw with the carburetor as much as you do with a tight lobe separation. Tight lobe separation cams have a lot of overlap on them. And because of that, the idle circuits have to be redone in the carburetors, and the jetting curve has to be changed, and there's a lot of things you got to change in a carburetor for a tight lobe separation cam. And if you don't know that, because the average guy is not going to know that, then it's very hard to tune. And if you can't find a good carburetor guy that knows that and knows how to tune it, then you're stuck with a poor running engine. So I understand why these guys put a wide lobe separation on them. The other thing is it builds a little more vacuum at idle too, so it's better for power brakes. But you know what? These are performance engines. We're not building these things for vacuum. We're not building them for, to be comfortable in traffic or whatever. And we will if that's what the customer wants, don't get me wrong. But that's not mostly what these guys want. These guys want an 11-second pump gas engine. And to get an 11-second pump gas engine, you got to have certain things. And one of them is in my opinion, tighter lobe separation. So we ended up using the cam that Andrew already had because I couldn't get a cam. Otherwise, it would have had a tighter lobe separation too, and we would have done that as well. But we did that, or we didn't have to do that, but we did degree the cam. The cam was out to lunch. We had to advance the cam a couple degrees to get it where we like it. And so that was another thing we addressed on this engine. And then the last thing that I can think of right now is the carburetor. Carburetors are a huge thing that people overlook. And this had a Holley carburetor on it, but it was a street carburetor. And when you're building an engine like this with Edelbrock heads and a performance cam and better flowing exhaust and all those things, you need a performance carburetor, not a street carburetor. So, and how you can tell a performance carburetor is they don't have a choke horn on them. The performance carburetors, the inlets are all radiused on them, and there's no choke on them, so you don't have that obstruction disrupting airflow. And it's a much better carburetor for making horsepower. So, and the other part is he had too small a carburetor on this, although it probably would have been okay because it's only 434. And I get flack for this all the time, but I'm telling you right now, this engine could use 1,000 CFM carb. We did not do that. We ended up buying an 850 carburetor, but we put a double pumper on it. The carburetor we took off was a vacuum secondary, and everybody's scared to death of mechanical secondary carburetors, and they're thinking that they're going to have street problems with them or whatever. But once a carburetor's set up, it's good. You don't have to deal with that, and it's fine. There's nothing wrong with a double pumper. As a matter of fact, I highly recommend it, and I prefer it because I feel like you have more control over your throttle than you do with a vacuum secondary carburetor. So that was the last thing that I can think of that we did. So now, what we have is we got a 10.5-to-1 compression, 434 cubic inch engine with a ported head, hydraulic roller cam that's 248, 252, I think, at 50, with a 114 lobe separation with an 850 CFM Holley Ultra carburetor double pumper on this thing. And we got it all dialed in. We got the fuel curve rate. We got the mechanical advance right in the distributor now, and all those things are fixed. And now this engine revs, and the revs smooth, and it sounds like it's supposed to, and it doesn't sound like a top fuel car. You would think with a cam this size that things would be going bah, 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 bah. It does not do that, and that's because we properly tuned this thing. And you're going to be amazed with this big a camshaft. It's got a nice idle to it, but it's not crazy and it's not stupid. So this thing will behave well at low speeds and in traffic with a hydraulic roller cam, as long as we don't have parts failure, because we've got so much of that going on right now in this world. But anyway, besides that, this thing, you could literally drive this car California if you wanted to with this setup. So I know this is long-winded. I'm sorry, guys. I didn't mean to be this long-winded, but it's important that you guys understand that you've got to have somebody that knows what they're doing build your engine, so that you end up with a good result the first time around and not 3-4 times down the road and several thousands of dollars later because you didn't think that the guy that quoted you an accurate price was fair. That's all I'm telling you. So we're into this thing now for like 16 minutes, my phone's showing here. So I'm gonna fire this engine up here. I'll be right back. I've got to make sure that everything's hooked up properly, but I'm gonna do that real quick, and then we'll start this thing up, and you can see how it idles. We've already warmed it up. This thing's got a 160 thermostat in, it runs nice and cool. So anyways, I'm done talking. We're gonna fire this thing up, let you listen to the idle, see how it revs.